morning, one and all. On behalf of the Institute, I welcome Professor Ashok Pundir, who is Professor in Operations Management at NITI Mumbai, for conduct of pre-submission, two pre-submission seminars. The first one is on modeling quality cost management system in advanced manufacturing environment. The PhD scholar is Mr. Sanjay Mantri under the supervision of Dr. Jaju. And the second one is data-dependent modeling and analysis of the rejections in duplex mold casting by Mr. Thakare under the supervision of Professor A.G.Thakare. So, with the permission of the expert, can we begin with the presentation? Yeah.
Good morning, sir. Good morning, Dr. Jaju, Dr. Wankade, Dr. Kiddan. My work is on, this is the title of my work, Data-Dependent Modeling and Analysis of Reactions in Duplex Mold Casting, under the guidance of Dr. A.G.Thakare. So these are the contents today I am going to explain. So as my problem is about duplex mold casting, first I will tell you why we have selected this particular area of research. So when we are seeing this casting process and visited this NECO industry, we came to know that there are a lot of rejections.
Which industry?
In NECO. Very yes, NECO. So they are rejecting many castings, but the methods they are adopting, they are not enough to find out the actual reasons of rejection. So this process itself is very complex, and there are a variety of defects which are very difficult to analyze. And the biggest problem of this casting industry is that there is no system by which we can predict quality. So there are a lot of productivity concerns, a lot of uncertainty. There is no system by which we can tell or say anything about the quality of castings. So primarily, this is the objective we have set. The first and foremost objective, the first objective was we wanted to develop a quality rating system. So the thought came in our mind that if we can express the quality of castings in terms of numbers, then it will be naturally better. So we wanted to predict the quality rating. Then we wanted to develop quality assurance system, find out the reasons responsible for rejection, and develop a model by which we can relate the output with the input. These are the causes. So our approach was applied to duplex mold casting problems is at NAGC, that is NECO industry. So this is the workplace, NECO Heavy Engineering Castings Limited. Although they are manufacturing number of components, variety of components, they have manufacturing capacity of around 30,000 metric ton per year, covering a wide range of products. And this is the problem area we have selected. This is called as a duplex mold. Although there are a number of products, we selected this. This is a duplex mold. So the weight of each mold varies from around 440 kgs to 600 kgs. And this mold is basically used for manufacturing pencil ingots, which are further processed into different products like angles and wires, etc. So the weight, almost half ton of material goes into manufacturing of this duplex mold. And what we find out in that industry is that if you reject a single mold, and there were so many rejections, the rejection level was right from 4%, it goes up to 12%, and most of the rejections were happening in rainy season. So if we reject even a single duplex mold like this, which is weighing around half a ton, it will definitely affect the cost of manufacturing, and this is a big issue with this casting manufacturer. So what we did, So we have tried to reduce the number of defects. So we analyzed the data. There was a lot of data available. The problem was that they are all adopting hit and trial methods to accept or reject these modes. And when I have gone through the data, they have provided the data of almost last 3-4 years. When I have gone through the data, I have found that these are the main defects which were repetitive in nature. There were many defects, but these were the main defects, that is cap surface, subsurface, sand inclusion, and cold shut crack and dimensional region. So we have concentrated on these 6 defects, which were mainly contributing to the rejection of this duplex mode. So in order to analyze the casting defects, first I have gone through the literature which is available, see how people are actually analyzing this problem and how they are overcoming this sort of problem. So while going through the literature, I have observed that people are adopting different techniques, and most of the techniques, either they are using these SQC techniques or they are using expert. They are using these expert systems as well as simulation. This is also quite popular. Then some of the researchers, they are also using hybrid methodologies. So like the first one, DOE, so they are combining the 2 methodologies in order to get the advantage of benefits of both the methods. Now, as far as the literature is concerned, I have gone through many papers, but these are the few papers which I am using it for the representation purpose. But what I found was that initially the paper which really helped me was paper number 36, Masayo. He has used some technique called as proposed score method, that is called as AHP. This paper was quite helpful to me. Second paper, recently Mr. Banchura, he has applied this AHP again for casting defect analysis. And the third paper, which was quite useful to me, was this demerit control chart using linguistic weights by Long VHA. So these papers were quite useful to me as far as my work is concerned. So this is about construction of demerit control charts, which I have utilized further. Then there are many methods, expert technology, etc. ANL is also quite popular with the researchers. And I have also gone through, because we wanted to use this GM-based methodology, I have also gone through these papers as well. But as far as the literature review is concerned, I have not come across a paper in which they have directly used GM-based for casting analysis purpose. All the other methods are used.
This proposed score method, what exactly?
Yes, it's basically AHP. I will come back to it in the next slide. That is basically AHP technique, whereby the quantitative numbers are given depending on the severity of defect.
It's a method to rank.
Can you write a little more, because anybody will get confused by writing on the proposed score method by using SC, whatever you want to say.
Yes.
Subsequent.
Because in detail we are in this slide. So these are some of the approaches. References. Yes. So these are some of the approaches adopted by researchers. Artificial intelligence, SQC is quite popular. Hybrid approach few people are using nowadays. Then simulation and artificial intelligence also, they are also quite popular with the researchers. Now these are some of the research gaps I have identified. So when we are analyzing a complex problem like casting, the presence of variables or the consider the interrelationships among the variables is very critical as far as the analysis of casting defect is concerned. Then we should also, what I found is that researchers are using many methods, but the problem is that although they are analyzing the variables which are affecting the quality of castings, but nobody has predicted any measure of performance. What is the quality of product, what is the quality of casting in terms of numbers. So this was one of the major drawback. So for that purpose, we are trying to develop a methodology by which we can measure the quality of castings, called as quality index. Then there has to be some methodology powerful methodology by which we can locate the vital few defects which are affecting the quality of castings and remove the trivial many. Only important defects should be focused on, which are leading to rejection of castings. And if we have some model by which we can relate the output with the input, it will be immensely beneficial. So these are some of the gaps. Although people are doing various things, but if we can relate the output with the input, it will definitely lead us to better idea about the defect analysis. So it's a very complex process, and we wanted to look at this issue by using some proven methods. So we have observed that in the data which was available was mostly analytical. It was mostly analytical. The big problem was that if we are analyzing the data, if we have quantitative type of data, it's always better. The quantitative type of data was quite less as far as the analysis was concerned. They are using analytical methods, that the casting is good or bad. But so our aim was to develop a comprehensive hybrid approach. So this methodology is expected to be a general tooling approach to solve similar kinds of problems. So this was our methodology. First to develop a measure of performance. So this was our methodology. First to develop a measure of performance. Then to rank the defects according to their severity. Then by using some fuzzy techniques. So then the demerit control chart, AHP, this is the score method, and GFDH. This is used for modeling purpose. So AHP was basically used for the score method to rank the variables. So wealth of data is available, but most of the data goes unused. So if we can find some information from the data which is helpful for patrolling the defects, it will be quite vital. Like it's a data mining approach. So as I said, the reaction goes up to 12% maximum. So data collection. So I had the data of last 3 years. So this is what I analyzed. Once I got all their data, this is what the basis of their rejection. They know the type of defect. They know in which month the castings are rejected because which type of defect. But further, they don't do any further analysis. It is completely on hit and trial basis. So I analyzed the data for
Month 1 is January.
Yes, ma'am.
Month is January.
Yes.
Number 1 is
January.
One is from March to March.
March to March.
One is
Financial year.
March to March.
So where do you find the rejections are high? Which type of rejections are high?
Yes, sir.
Some seasonality in the rejections.
Yes, in rainy season they have the higher rejection levels. In rainy seasons. It mostly goes up to even 12% in rainy seasons.
Why? Reason?
Because of the atmospheric conditions, environmental conditions. So the temperatures are drastically changing. Environmental conditions are drastically changing in rainy season. And the lead rejection was in summer season. It was around 2-3%. So the data we have analyzed. So in order to get the idea about the data was available, but the problem was that causes were not known. Even the defects were known, but the causes leading to the defects were not known. So what we did, first we developed a questionnaire. This questionnaire was administered to around 75 companies, but the problem was that we could not get the kind of response because for duplex mode manufacturing the number of manufacturers are quite less.
75 people, no?
Yes, 75 people. We admitted 75 people. So,
Not 75.
administered to 75 people. And but what we found that we actually, but we have preferred the responses from the NECO and its sister concerns. So around 25 references were selected for our study. So this was our methodology.
These responses were mainly in Nagpur region, or they were?
No, they were from
Huh?
yes, sir, from Aurangabad, then from Nagpur, then Raipur, then Bhilai. So they were through their. I have mostly used their references only.
The manufacturers and users of weather conditions. Weather conditions. Basically users also.
So this is the methodology we have developed. So our major purpose was first we have identified the problem areas, then develop the questionnaire, pilot test, then finalization of questionnaire, then to develop a measure of performance of quality. After developing the measure of performance of quality, we wanted to know the ranking of critical causes which are leading to rejection. And after knowing the ranking of critical causes of rejection, we wanted to develop a model by which we can relate the defects with the results. That is the output with the input. So these are some of the feedbacks of industries according to employees position. So we have mostly given weightage to people who are who really know how the process goes about. So they were giving more. They were given more weightage. So the person should also know the exact. He should have know about this process.
So none of the above means who are those people?
Who are those like shop floor, etc. So workers also, they also participated. They were also very interested in this analysis. But we are not considered, not given much importance to it, because what analysis, what we wanted to know, we were not getting the feedback from it. Mostly the feedback, good feedback was from this managerial level.
So these people were not considered.
This paper was the importance was not given. Importance was not given. Although they were quite ready to fill up the questionnaire still. So these are the defects and the causes. So the principal defects, as I said, we have listed 6 major defects which were leading to rejection of this duplex mode. So, and going through literature as well as the discussion with the people in that industry, we also listed the causes which are leading to these rejections. So for SCAT, these are the causes. For subsurface, the causes. We have listed down the major causes which may lead to these defects. So then we have gone for the data analysis. Our questionnaire was mainly divided into 4 parts, which was mostly qualitative in nature. And experts, assessment was done by the experts of the importance of different causes, different parameters which are leading to the rejection of the castings. Then for analyzing the data, we wanted to convert the linguistic, means the linguistic meaning words, into some value, that is a numerical value. So this also we wanted to do. So that was also included in the questionnaire. These are the steps for data analysis. As I said, our main purpose was, the first step was to have some measure of quality of the castings. So for determining the measure of quality called as quality index, we have used this demerit control chart. So it's a statistical techniques. So once we use the demerit control chart, by using the demerit control chart itself, we can know the quality indices. They can be calculated on monthly or yearly basis, depends. So to know the quality of product, quality of casting, we have used the demerit control chart. That was our first step, to know the quality of product. The second was, after determining the quality index, we wanted to determine the level of seriousness of different variables which are leading to these defects. So for that purpose, and this is a typical multi-criteria decision making process, so there are a number of parameters involved. We wanted to know which are important and which are less important. And third, once we determine the quality index, we should have some model by which we can relate this quality index with the causes. So that was our third step. The first was to determine quality index, second was to determine the weight according to severity, third was to develop a model which can lead to, which can give us better idea about the output and the, or we can relate this output with the input, that is the defect and the causes. So for that purpose we have used this methodology GMBH. Now demerit control chart. The first thing we did is we have gone for this demerit control chart to know the quality of these castings. So what is a demerit? It's a measure of scoring the severity of defects. This chart was introduced by A.G.Thakare in 1928. The purpose was that what he said, some of the defects had very serious consequences on the performance of the products and some are not. Severity differs. So first step, the demerit control chart. The second was, the classical approach was suggested by H.F. But after using this classical approach, we have also plotted this demerit control chart by using these linguistic weights. I will come back to it later on. The third was analytic hierarchy process. This was used, since this is a multi-criteria decision making problem, this ASP which was introduced by starting in 1970, this was used to know the importance of variables according to their weight. And the third technique we use for developing the model is GMBH, which is a type of inductive algorithm, which was originated by Professor A.G.Thakare in 1968. So this is used in many fields like data mining, knowledge discovery, etc. So this is how actually this GMBH network works. So this has number of layers. Every layer has number of neurons. So this will be our input, x1, x2, x3, x4, the variables which are causing the defects. So every layer has neurons and every neuron has two inputs and one output. And finally, it gives us the best solution. It will remove the vital few, it will remove the trivial many and keep the vital few only. So as most of the data was qualitative, we wanted to know the quality index. For this purpose we use this demerit control chart approach. So this is how the classical demerit chart control chart, classical method of construction of the demerit control chart. What Ghrce suggested in his method, he suggested that the defects should be classified into these four categories. That was his suggestion. This is called as the classical approach of plotting the demerit control chart. So if we can classify the defects into these four categories depending on their severity, all the critical defects, they will be put under class A, then serious defects will be put under class B, and the defects which are not severe will be put under class D. And he has suggested that after dividing these defects into number of classes, we can assign them weights like this. So this weight assignment can be arbitrary as well, but he has suggested his scale 100, 50, 10 and 1. This is the classical approach. So classify them according to severity into these four classes. Classify the defects into these four classes. So we have used this methodology.
So followed the exactly same way.
Yes.
We have changed.
Yes. For classical method, we tell you. So for the
Only
four classes. He suggested only four classes. That is the classical approach. So we have analyzed the data for the first year. After analyzing the data for the first year, we have calculated the number of defects which can be put under category A, which were found to be very critical. So similarly, the defects were classified into these four categories by using this methodology. So number of defects, number of critical defects, 25. This is for the whole year. Number of the second level, at the second level, 40 defects. And at the bottommost level, the 42 defects. So this was the whole year's data. And the number of defects they were put under these 4 categories, which were leading to rejection. Now, after classifying the defects into these 4 categories, we have used the data for construction of the demerit control chart. The method was very simple: calculate upper control limit, lower control limit, and center line. But this is how I have summarized it. So this is for the first year. This data is for the first year. Now, this is for month 1. The size of the lot was around 400 pieces. So after analyzing this data, in which 400 pieces were manufactured in the first month, the defects were classified. The defects which were observed were analyzed. They were classified into these 4 categories. So after classifying the defects into these 4 categories for the first month, we have calculated the demerits. That is nothing but a multiplication by multiplying this by the weight. We get the total demerits. So after calculating the total demerits for month 1, we have calculated demerits per unit. That is 536 by 400 for the first month. And this expected demerit, this is the center line we have calculated on the basis of this data. So center line we have kept as the expected demerit. This is what we were expecting. So this is the expected demerit. So for all the 12 months in the first year, by using this classical approach, we have calculated the total demerits as well as demerits.
How did you get this expected figure?
Expected, that is the center line. When we have calculated upper control limit, lower center line.
X bar.
Yes, X bar, center line. So this is the data: demerit per unit, upper control limit, lower control limit, and center line. And we plotted the demerit control chart for year 1. So after looking at this chart, we came to know that we came to know that the quality is changing drastically. Then we have calculated the quality index. For quality index purpose, then quality index is calculated for all the 12 months. We wanted to know the measure of performance. This quality index is our measure of performance of the casting. So for calculating the quality index for all the 12 months, so we have calculated for all the 12 months. This index is calculated on the basis of the demerits which are observed divided by the expected demerits. So the demerits observed divided by expected demerits leads us to the quality index. So that is how simply we have adopted this technique of classical approach of plotting the demerit control chart for calculating the quality index. That is how we have calculated the quality index for all the 12 months in the first year. So the quality index is changing drastically for the first month. Similarly, we have classified, we have also plotted the demerit control chart for year 2. Then again the same calculations, demerit control chart, index, and the quality index. Similar process we adopted for year 3 as well. Demerit control chart and the quality index. So this is how we adopted the traditional approach, the classical approach for knowing the quality of product. This was a Dodge approach. Now, the problem was that the problem with classical demerit control charts is that we know that the severity levels of the defects are different. Defects may be highly severe, defects may be less severe. So we wanted to make it more sensitive. We wanted to make this demerit control chart more sensitive. We wanted to reduce the control limits so that the process can be controlled in a better manner. So we have gone for this approach called as demerit control chart using linguistic weight. So this is basically a fuzzy approach, whereby we are assigning the weights called as linguistic weights. So fuzzy scales we have used. Now there are different scales which are available in the literature. Number of scales are given by the researchers, but we have adopted this scale which was suggested by Chen and Meng in 1992. This is basically a 11-point scale. Different scales are available: 5-point scale, 7-point scale, 8-point scale. They are available. But we wanted to make the data more sensitive, to have more idea about the process. We have gone for this 11-point scale. This scale was suggested by Hong in 1992. And the scores were also given. These are the fuzzy numbers, M1 to M11, and the scores. So depending on the criticality. So most critical most critical cause will be given a weight of 0.955 and least critical will be assigned a weight of 0.045. So this is the pre-score assignment for
discrimination.
so this scale we have devised for analysis to plot the degrade control chart using linguistic weights. So these are all the defects leading to rejection. These are the causes. Then every cause was again classified into these 4 categories according to its severity, and the scale was assigned by using that fuzzy technique, fuzzy numbers. So every cause was classified into these 4 categories. So there were around 26 causes. So these are the 26 causes. For all the 26 causes, we have developed a scale. Now by using that scale, again we have analyzed the data. For year 1, by using this 11-point scale, we have classified the number of defects according to the severity. So this is data for the whole year. And again the similar calculations, we have calculated the quality index, upper control limit, lower control limit, demerits for it. Again we have plotted the demerit control chart. So this is the quality index we have calculated by using linguistic weights. Similarly, the process is carried out for year 2. In the demerit control chart. So for all the 3 years, we have plotted the demerit control chart and the quality index by using linguistic weights. So what we came to know after plotting this demerit control chart, we came to know about that the quality is changing drastically. Even the index is changing. There is change in quality, but we could not find out the actual reasons why the quality is changing. That is the problem with demerit control chart. Also, although it leads to measure of performance, but it does not give you the idea what is the problem, why the processes or why the points are falling outside the control limits. That is the problem. So these are the calculations. So by using this, we can land up at the reliable quality index. That is the advantage. And this fuzzy system provides a more realistic and accurate assessment of quality index. So we have suggested, rather than going for classical demerit control chart, we suggest that we should use a demerit control chart based on linguistic weights. That is the fuzzy. So it will give us, the chart it becomes very sensitive. So as I said, when we plotted the demerit control chart, we know the product quality, but we do not know the importance of different causes. Which one is critical and which one is least critical. So we have gone for this score method. So there are many. So this is typically a multi-criteria decision making problem, and there are many MCDM methods, but we have used AHP for our analysis. This will be our score method. This is how the AHP works. The problem is divided into hierarchies. The goal will be at the topmost level. These are the alternatives. These are the criteria. These are the alternatives. Even we can go for more level. So basically, the AHP works on the principle that if we can put all the elements in a structured manner, we can analyze them in a better way. So this is how AHP structure is. So for AHP analysis, this technique was basically suggested by the starting. And he has also suggested this scale. So this scale is called as static scale. So these numbers, they show the preference of one factor over the other. That these are called as the priorities. And this is the AHP model we have suggested. Our goal was to identify the most critical causes of defects. So these levels. At the first level are the criteria. So our criteria were man, machine, method, material and environment. At the second level are the alternatives. At the alternative level we have placed these different types of defects. And at the third level are the causes which are leading to these defects. So these are the causes leading to scab. These are the causes leading to subsurface, causes leading to culture, etc. So first is the goal, second is the criteria, third is alternative, and fourth is subalternative. I will tell you the process for calculation. In this AHP model, when we calculate the weights of different causes, all the alternatives were analyzed on the basis of criteria 1. All the alternatives were analyzed on the basis of criteria 2. As well as, so on the basis of every criteria, the alternatives are analyzed. Similarly, on the basis of every criteria, the sub-alternatives are also analyzed. So on the basis of man, we have analyzed all the 26 causes. On the basis of machine, all the 26 causes, like that.
This
So-
environment cause what all?
Yes, sir?
Environment class. C5.
Environment.
Yes, yes. Environment.
Oh, what do you consider?
In environment, matlab temperature variations, then rejections which happen due to this conditional differences in, like in rainy season, there are so many changes in the environment. So this is the environmental type of thing.
Temperature.
Yes, yes, yes. That is also one of the critical reasons. So we have placed it as a criteria. So then the questionnaire we analyze on that. So this is the SATI scale. So this is for criteria ranking. This is how we analyze the questionnaire. The criteria is that these were the 5 criteria and the number of responses under every individual scale. So as I said, we have considered about 25 feedbacks. On the basis of these 25 feedbacks, these people have classified this. Suppose for man, scale of ranking 5, so 3 people have ranked it at this scale, 10 people have ranked it at this scale, 7, like that. Similarly, alternatives, the analysis was done. Then the causes, these are the sub-alternatives. Again, there was analysis. All the causes. And we have developed a matrix. So, after analyzing that, the feedback for criteria ranking. Now, the basic purpose of AHP is that we wanted to rank all the 26 causes into from critical to the least critical one. So this is one of the matrices I have shown for the criteria. So we have these 5 criteria. So this is the matrix which we have developed. And as I said, this basic principle of AHP is that we are finding the priorities. So suppose if we compare this C1 with C2, it means that priority is given by more number of people to machine than the man. So naturally, if machine has been placed at a priority of 9 compared to man, it means that C2, that is machine, and man. So this will have it's reciprocal. So this is the calculation part. We have calculated the overall weights, and this is the final ranking. So as I said, we wanted to know the critical causes leading to the rejection. So once we come to know these weights, from these weights we came to know that this is the most critical reason. This is number 2. Similarly, all the 26 causes were we came to know in the order of importance. So the problem with the first problem was that we have used numeric control chart. It did not lead us to the reasons. AHP we use. By using AHP, we came to know the weights. We came to know that this is the critical one and this is least criticality. But the problem with AHP was that AHP was not able to lead us to a model by which we can relate the output with the input, that is defect with the causes. So we have gone for this third method called as GMDS shape. So for a GMDS shell, all the 26 causes were our input variables. So again, for the last 3 years, we have analyzed the data, and the variable to be predicted, this is our Y, that is the output, that is quality index. So what we did in this case, what we did in this case is that we have related this quality index with the causes and develop a model, which AHP was not able to do. This is the data we have analyzed. So by using that scale, 11-point scale, the whole data for all the three years, it was analyzed. A scale was assigned to all the causes depending on their severity. And this data was given as input to the GMDH shell software. We have used this GMDH shell software. So now in this case, the variable to be predicted is y, that is quality index. So this is our final column, that is output. This is the variable to be predicted, that is quality index. So we had already calculated the quality index for all the 36 months. So in that column, all the 36 values were put. Then input variable selection, all the causes, these are all the causes, 26 causes. This becomes the input for that GMDH. Then this is the training testing data, so 20% for testing. And this is the result we got, simulation result. So naturally, if we look at this, now this is the actual data shown by grey lines. And these are the model fit values. And these are the predicted values. These are the residuals, difference between the actual and the calculated values. And the accuracy. The best advantage of using GMD is that we can get a highly accurate model having correlation coefficient of 0.9% and 0.90 and above. That is the best advantage of using this GMDH. So high accuracy model is possible by using this GMDH. This is the model we got. This is the final model. So this is what we wanted to know. These are the causes. GMDH also, as I said, the basic purpose of GMDH is vital few and trivial thing. So keep only those variables which are important to the problem. Remove all the variables which are not important to the problem. So out of 26, GMDH has told us that these are the 14 variables which are mostly responsible for causing the defects. So on the basis of root mean squared error, we knew that these are the 14 most critical causes leading to the rejections. So this is the model we got by using this GMDH. So in this case, this N388 and N3, these are called as the intermediate variables. And these intermediate variables, so there are number of layers. These intermediate variables are also expressed in terms of other variables. So this goes on. So we got around 9 levels. All the intermediate variables are defined in terms of. So this is our conclusion. So our main purpose was first to know the index of quality, that is measure of performance. Second, to know the ranking of variables according to their criticality. Third, to relate output with the input. So we have related this quality index with the causes and develop a model. So this combination, this is something called as a hybrid approach, whereby we are using this AHP and GMDH. This enables us developing a high accuracy model, correlation coefficient of 0.90 and above. So we can identify significant parameters by using GMDH. Important defects are determined in order of priority, that is by using AHP. And this hybrid methodology, whereby we are combining this fuzzy logic with AHP and GMDH, is suitable for developing data-dependent model essentially for a qualitative process. This is the feature scope. So this is a typical multi-criteria decision-making problem. Such kind of methodology, this can be viewed as a general tool to solve similar kinds of problems. The advantage is we can identify principal parameters responsible for the performance of complex system, since casting itself is a complex process, and to take corrective actions by extracting rules directly from the database. Lot of data is available, but it is unused. So we can,
This again with respect to
with respect to,
foundry only, complex system.
yes, yes, foundry. Any multi-criteria decision making problem.
Extended to any
MCD, a similar kind of situation.
which is complex. Just an example to demonstrate the method.
So these are some of the papers.
So from one type of foundry to another type of foundry,
Yes.
it can be replicated.
The methodology can be used. Methodology can be used, definitely. Similar kinds of situation, this methodology can be effectively used.
From large industry to
Oh,
small
definitely,
industry.
definitely. GMDF is so powerful, HP is so powerful. HP is quite simple in fact.
If the results will be impacted if you have the more automation or less automation.
Definitely. Definitely.
Some places they are very primitive, some places
If there is more automation, the more data will be available. That will be even better.
This is not restricted to foundry. This is a methodology where things are very complex, where we are trying to find order out of randomness, order out of disorder. So something is not known, something is not known. And then systematic methodology by which data mining. So it focuses on methodology rather than foundry. Foundry is just an example. It's an approach, it's an analytical approach that has been developed. Hybriding.
Next, anybody to ask.
Anywhere.
What other industry you can make?
Other industries.
What other industry you can make use of it? That you should be ready with the answer. You know,
Yes,
just
sir.
by saying complex system,
Yes, sir.
you cannot escape. You have to know
8-10 complex systems we must be able to get.
different type of system, whether various forging industries are there, then there will be many automobile industry, many places, you know, some of those complex systems there, whether assembly line or whether it is manufacturing. So those different type of industries, movement is a complex system, anybody will ask you questions.
Yes.
Professor said, trying to find out order in that disorder. No?
Order in disorder.
Finding order out of disorder.
You're familiar with it, no?
Yes, sir.
What professor says, finding out order in disorder. no?
Yes, sir.
Right? In a traffic jam also you'll find there is a one lane is always keep on working, you know. There is a traffic jam, but you still will find some lane is working. The vehicle keeps on moving. Stock market also.
Yeah, anything. Variables are many.
In fact, GMDH is quite useful for stock market.
So there you should highlight this.
Yes, sir.
Don't leave it to
GMDH people are
complex.
using in stock market.
Unless you want to leave it to the people
This is very normal regression. We have limited variables. Here we can go infinite. Literally 25, 30.
What I asked you to do is these will not come out there. These not demonstrated. You mentioned here,
Yes, sir. Industry.
they mentioned where all it can be applied.
So already लिखला है सांगितलं.
It's there.
Forecasting or
Cement and port.
stock market. Complex systems कोणते?
You should highlight them. All the best.
On behalf of the institute, I am thankful to Professor Ashok Pandit for accepting our invitation and being here for the very purpose of conduct of the pre-submission seminars of two scholars. And I assure that all the suggestions which have been made by you, each suggestion will be incorporated in the thesis, and we will make it a point that unless and until all this is done, we will not forward the thesis to the university. So thank you, sir. Thank you one and all.